there are a couple different lines that are parallel to FE. So FE, so this is a cube. Say that all these intersect and make 90-degree angles. So they're a bunch of squares. So FE is kind of right back here. Something that's parallel could be AH. So line AH, that could work. And that would be this back plane right here, this square. Also, if you did like a GD, but then you're in a different plane, you're in this plane right here, this sheet of paper. So GD would work, or AH, or even you could do BC. And this plane would be kind of like if you put a diagonal here and here, it would be this plane right here that would touch both EF and BC, and those two lines would be parallel. So 3 different answers. Perpendicular to CD. CD is this guy, so what hits it at a 90 is either this, because there's a 90 at CH, that intersection, or there's a 90 right here at BC, at that intersection. So either of those 2 lines. Okay, a skew line to BC. So BC goes forever up and down right here. A skew line could be this line right here, GF. So these lines will never ever intersect because they're in 2 different planes, and those 2 planes are parallel, so they're never going to cross. Okay, a parallel plane to BGC. So it takes 3 letters to mark a plane. So BGC is this plane right here, and a parallel one would be the one in the back, plane AFE. So this plane in the very back. Okay, number 5, 6, 7, 8, 9. Just name the relationships. So 3 and 6. 3 and 6. Those are alternate interior. 4 and 6. They're on the inside, so they are interior, but they're on the same side, so they're consecutive interior. 2 and 7. 2 and 7, they're alternate exterior. 1 and 5, 1 is here, 5 is here. They're corresponding, they're in the same position, they're both in the top left. And then the last one, 1 with 8 and 1 with 8, those are alternate exterior. Okay, now these markings are a big deal. These are parallel. So when these lines are parallel, the angles are all either supplementary or they're congruent. So they're the exact same size, or they add and give you 180. So this angle right here and this angle right here are vertical, they're congruent. And this angle is corresponding with this one, so they're congruent. So these 4 angles are all the exact same size. You gotta find the value of X and Y. Alright, so this smiley and this smiley are the same, but this smiley and this star and this star are congruent, and this star and this star, so all the smileys are the same, all the stars are the same, but the stars and the smileys all add and give you 180. So this 9x plus 12 and this 3x, so the 9x plus 12 and the 3x, one is a smiley and one is a star. So they're not congruent, but they will add together and give you 180. So this much add this much will total to be 180. So if I've got 12x, if I add my like terms, my x's, plus 12, and they equal 180. So now just solve for x. It's just a linear equation. So minus 12 minus 12. So you have 12x is equal to 168. Then divide by 12. So you should end up with x is 14. Okay, now I'm going to plug that in and find the measure of that angle. So the angle says whatever x is, you triple it, 3 times x. So if I times this by 3, this angle is 42 degrees right here. Okay, now if that's 42, I know that this one has to be 180 minus 42. And 180 minus 42 is 138. So this has to be 138 degrees. So that means my 4y minus 10 has to equal 138. So add 10, add 10. 4y is equal to 148. Divide by 4, divide by 4. Y, 148 divided by 4. Y is 37. Okay, number 8. Same thing. So these lines are all parallel. When they're parallel, everything is congruent or supplementary. So this one is the same as this one, which is the same as this one. Same here, and same here. So all the smileys are congruent. And then all the stars are supplementary to the smileys, but they're congruent to each other. So that star equals that star, that star equals that star, that star equals that star, and all the stars are the same. Okay, so I need to find y and I need to find x. I'm going to put my y's together. So this y is a smiley and this y is a star. So that means they're not congruent, but they will add and give you 180. So if I do the 5y minus 4 and I add it to, what was that, 3y? I covered it up. 3y. Man, where's my mouse? They will equal a total of 180. So add up my y's. 8y's minus 4 equals 180. So add 4, add 4. 8y equals 184. Then divide by 8, divide by 8. Y is equal to 23. So y is 23. Now, if I know y is 23, I need to find x. So I'm going to plug 23 in right here to find how wide this angle is, because this angle and this angle are the exact same. They're corresponding, so they're congruent. So 3 times 23 is gonna be 69. 69 degrees is this angle, and 69 degrees is this angle. So that means 2x add 13 is equal to 69 degrees. So minus 13 minus 13. 2x is equal to 56. So divide by 2, divide by 2. X has to be 28. Okay, number 10. This is 90, and these two added together are also 90, because it's a straight line. There's got to be 180. So x add 4x has to equal 90. 5x is 90. Divide by 5. Divide by 5. X equals 18. Okay. Next page. Okay, now triangles. If I give you 3 lengths, determine if they make a triangle, yes or no, and if so, what kind of a triangle does it make? There's three types: a 90, obtuse, or a cube. So a 12 and a 30 and a 14. Okay, this one's the biggest. You gotta find the biggest. And then if the other two sides, so we got 30 right here. And then you got a side coming off that's 12, and you got a side that's coming off that's 14. Now, if you swing these sides around, do they touch, or do they just sit and swing and never touch, or do they fall back to the base? So 12 and 14, the total length of 12 and 14, if you add them together, is 28. And 28, they'll never touch, because the bottom's 30, so they got to be at least bigger than 30. So you take the two small ones, add them together, and if they are bigger than the base, they will touch and they'll make a triangle. If they're smaller, then they will not make a triangle. So 11 will not touch, they will not make a triangle. 12, okay, the big one's 20, and 10 and 11 is 21. 21 is bigger than 20, so it is a yes. Okay, now, which of the three types will it make? Okay, the big side, this big side is always going to be C. The only way to tell is to do some Pythagorean theorem. You got to do a squared plus b squared is c squared. Okay, so 20 is going to be my C. So I'm going to do 10 squared plus 11 squared, and I'm going to see if it's equal to 20 squared, if it's greater than 20 squared, or if it's smaller than 20 squared. So 10 squared is 100, 11 squared is 121. Add those together, and that's 221. 20 squared is 400. Okay, 400 is bigger. So if the biggest side is bigger, then it is obtuse. So number 12, they touch and they make an obtuse. So when the bigger side is bigger, it's obtuse. 13, okay, the biggest side is 97. So add up 65 and 72. 65 and 72 is way bigger than 97, so it is a yes. So it's going to be 65 squared, add 72 squared. Those are the two little ones, and let's see how they rank to the big one, 97 squared. Okay, now, this has got to be calculated. 65 squared, add 72 squared. These two total and give you 9,409. 97 squared is 9,409. So when they're equal, that means it's a 90. So it's a right triangle. Okay, 14. Who knows what this number is? 5 times the square root of 2. You got to do that on your calculator. 5 times square root of 2, because we get a better idea if we look at the decimal value probably on square roots. So 5 square roots of 2, that's like 7.07. So it's in between 7 and 8. So it's some crappy decimal. Okay, that means 11 is the biggest. And if I add 10 and 7.07, that's like 17. That's bigger than 11, so it is a yes. So 11 is the biggest side. So it's going to be 5 square roots of 2 squared, add a 10 squared, and let's see how that ranks up to 11 squared. Okay, 11 squared is 121. 10 squared is 100. 5 square roots of 2 squared is 5 square roots of 2 times 5 square roots of 2. So the 5's times together, and that's 25. The 2's times together, and that's 4. And square root of 4 is 2, so 25 times 2. These square and give you 50. And if you add it to the 100, that's 150. And 150 is greater than 121. So if the little guys are bigger, that's acute. Okay, now we move into special triangles. Special triangles are going to be 30, 60, 90, or 45, 45, 90. Draw the rest of the picture. 30, 60, 90 comes from an equilateral triangle. So number one, 30, 60, 90. 30, 60, 90 is half of an equilateral. All sides are the same. An equilateral, if you cut it in half, 60, 60, 60, it takes that 60 and makes two 30s. So you always flip it over the 30. So here's the 30, there's the 30. Two 30s is a 60. So the rest of my triangle is right there, the ghost half. Okay, now, if you're looking at the whole picture, it's just a lot easier to fill in all the pieces. That's one, so that's two, and then to find the middle, you take the side that's cut in half, you take the short piece and you times it by a square root of 3. So m is 2 and n is square root of 3. Okay, now number 2, that's the 30, so draw the ghost half. The ghost half is right here. Okay, that's the square root of 3 and that's the square root of 3. So you either add them together or times it by 2, and these are 2 square roots of 3, and this is 2 square roots of 3. And then the middle is just the shorty that got cut in half, square root of 3 times square root of 3, and that is a square root of 9, and that is the whole number 3. So y is equal to 3, x is equal to 2 square roots of 3. 3, okay, 45, that means that's a 45, because in a triangle they all got to add to be 180, so that's 90, these two got to add and be 90. The ghost half is right here. 45, 45 comes from a square. Okay, now they gave you the hardest one possible, because in a square, if they give you the outside edge, then all the way around is 5, 5, 5, and the diagonal is always the outside edge times square root of 2. So if they give you the middle, you got to go backwards. You got to take the middle, 5 square roots of 2, and you got to divide it by square root of 2. And that will give you your outside edge. So your outside edge is going to be 5 all the way around. Okay, number 4. That is a 30. So I flip it over the 30. 2 30s makes a 60, and we got a 60, 60, 60. Okay, that's 20, that's 20, and that's 20. That means this guy's 10, this guy's 10, and the middle is 10 times the square root of 3. So that was pretty easy. But the hardest one is when they give you the middle. None of these give you the middle. So if you have like a 30, say your 60's there, your 30's here, if they give you 10, so you draw the ghost half, the whole triangle. When they give you the middle, that's the worst. Just like a square, you've got to work backwards, so you divide. So you work backwards to the shorty piece, and you take the middle, and you divide it by square root of 3. And then you double it to get this one. But never leave square roots in the bottom. Okay, number 5 is kind of like a 2-step process. You're given 2 triangles, one of each. One's a special 30-60 and one's a special 45-45. So the 60, let's play with that. You need to find x. So 30, 60, 90, this is 5. That means this is 10. And this piece is 5 square roots of 3. So I'm going to use that. There we go. This piece right here is 5 square roots of 3. Okay, now 45, 45, this is a square, so that's 5 square roots of 3, and the diagonal is going to be 5 square roots of 3 times a square root of 2, and these play together, so it's 5 square roots of 6 is the value of x. 6, we're going to start with the 45. We're going to start with the square. So if you're given the middle, you work backwards, divide it by square root of 2. So this is 8, this is 8, this is 8, and this is 8. And this is 30. So here's my ghost half. So if this is 8, this is 8, this is 8, that's 4, that's 4. So x is 4. And now, special triangles, but you gotta draw your own picture. So an equilateral triangle, let's draw it. Has an altitude, that's the height, that's this piece right here. So that is 33. Determine the length of the side, so they want to know what are the dimensions of this triangle. Okay, so if that's 33, I'm going to work backwards to get the shorty piece. So I'm going to take 33, divide by square root of 3. You can't leave a square root of 3 on the bottom. So it's going to be 33 square roots of 3 on top, and on bottom is square root of 9. And square root of 9 is 3. So divide 33 and 3. So this is 11 square roots of 3. That means this is 11 square roots of 3. So the whole length, you add them together. 11 square roots of 3, add 11 square roots of 3 is 22 square roots of 3. And this is 22 square roots of 3. So the sides of that triangle are 22 square roots of 3, which is some crappy decimal. Okay, the middle one, 45, 45, 90. That is a square. With a leg length of 77. Oh, the hypotenuse. Okay, they want this. So it's a 77 by 77. So that means this diagonal, this hypotenuse, is 77 times square root of 2. And then another square, 45, 45, 90. The hypotenuse is 38. Okay, so this time they give you that's 38, and they want to know how long are the edges. So you got to take 38 and divide by square root of 2. Times bottom by square root of 2 times top by square root of 2. So it's going to be 38 square roots of 2 over 2. And these play together, divide 38 by 2. And you should end up with 19 square roots of 2. 19 square roots of 2. Okay. Next was trig. Okay, in your trig, remember your calculator, make sure you go into the settings and make sure it's in degrees. Okay, solve the triangle. So we need to find the angle A, angle B, angle C, and then the side A, side B, and side C. Angle C is 90 degrees, and this 4 is side B, and the 6 is side A, and I need to find side C, so I'm going to do Pythagorean theorem. I'm going to do the little one squared, add the little one squared, and that is equal to the big one. The big one is always opposite to 90. That 90 points, that corner of the 90 points to the hypotenuse, and that is always your longest. So 36 plus 4 squared, 16 is c squared. Okay, now this is going to be nice. They want decimals, so we don't need to leave it in square roots. So we can just go decimal. So 36 plus 16, 52 equals c squared. Undo the square, square root, square root. So on your calculator, just punch in square root of 52 and then round it to a decimal. And that is going to be 7.2. Okay. Now we got to find an angle. either angle A or angle B. So I'm going to label this is 7.2. Okay, now you got to put theta in somewhere. So if I put theta right here, that means I'm looking from the perspective of A. So if you look from A, now you got to label your triangle so we can do the trig so we know what to do. If you go from A, 7.2 is going to be the hypotenuse. Now A, you go straight across, and 6 is going to be your opposite. So that means 4 is the adjacent. Now your trig, we can do so, ka, or toa. And in this case, I know the O is 6, I know the A is 4, and I know the hypotenuse is 7. I know all three of them. So if I know the O, the A, and the H, I can use any of the three and it will give me the exact same answer. So if I go for this one, if I go for sine, so sine, but then you got to tell me where you're going from. You marked it on A and you don't know what A is. So just say I'm doing sine from A, and I know the fraction is O on top, so that's 6, and H on bottom, that's hypotenuse, 7.2. And okay, you want to solve for A, but A is tied up in a trig, and the only way you can undo trig is to do the inverse. So to ditch sine, we gotta do inverse sine. So you do sine inverse on this side, you do sine inverse on this side, and if you type in sine inverse of 6 over 7.2, let's see, 6 over 7.2, that will give you the angle A. So angle A is 56.4 degrees. Okay, now angle B we can do without any trig. We can just do arithmetic. Angle B, this angle, this angle, this angle, they got a total to be 180. You're using 90 of it here. So that means A and B have to add to give you 90. So if you just do 90 minus 56.4, the leftover, that's what B is. So once you find one angle, the other one's pretty easy. So look at this guy right here. This is 90, this is 40. That means this has to be 50. Because 50 and 40 is 90, and 90 and 90 is 180. So that's pretty easy. So on number 2, we know all the angles. C is 90, A is 40, B is 50. Okay, now we just have to find side A, side B, and side C. And we know 11 is opposite of A. So 11 is side A. Okay, now I'm going to mark it from here. I'm going to mark it from B. So if I mark it from B, that means this is my opposite and this is the hypotenuse. So this guy is adjacent. Okay, now to figure out which trig to use, this one's a little trickier. You have 11. 11 is the adjacent. So you need to use one of them that uses adjacent. So sine is out of the question. That one uses adjacent and that one uses adjacent. So do I want to find O? Do I want to find the opposite? Or do I want to find H, the hypotenuse? And it does not matter. So I'll do this guy. We'll do tangent. So if you choose to do tangent, the equation is going to be tangent. You got to tell me where you're going from. You're going from the 50 degrees, and now set up the fraction. So tangent, the O needs to go on top. So the opposite goes on top. You don't know what that is. So call that x, and then adjacent goes on bottom. Okay, this one's pretty easy. So look, to solve for x now, x is just being divided by 11. So undo that divide 11. So times by 11 times by 11 on your calculator. If you type in 11 times tangent of 50, that will give you your answer. And the x you found was the opposite. Okay, so I want to show you this. Let's do cosine instead of tangent. Because I think that you'll get the same answer, but cosine, the equation is a little bit harder. Because look, if we do cosine from 50, cosine is adjacent on top, that's 11 on top, over hypotenuse on bottom. Hypotenuse you don't know what it is, so you can just call it x. Now, when your variable's on the bottom, that kind of sucks. This is one more step. It's a little more challenging. So let's call this x. To get x by itself, you got to get it out from underneath. So you times by x times by x. So you have x times the cosine from 50 equals 11. Now x by itself, get rid of the times cosine 50. So divide by cosine 50, divide this by cosine 50, and x is going to be 11 divided by cosine 50. That on your calculator is going to give you the same as the tangent. And then once you have this side, just do Pythagorean theorem to find the missing side. Or you could do trig. Okay, number 3. Now you got to draw your own picture, and you got to make sure C is the 90. So if you draw your own picture and you make C the 90, it doesn't matter where you put A and B. But they're telling you A is 55.6, and then side B is 7.1. So side B goes across from angle B. That's 7.1. And then I know angle B, I'm just going to do 90 minus 55.6. And this is going to be 34.4. Okay, now mark it. You got to start labeling opposite, adjacent, hypotenuse. So you got to figure out where you're marking from. If I mark from right here, that means this is my hypotenuse. This one over here is my opposite. And this one is my adjacent. Okay, so let's say I'm going to use O, and I want to find hypotenuse. So the only trig that uses O with H is sine. So you're going to do the sine from 34.4, and that uses O on top with 7.1 with hypotenuse on bottom, and you don't know what the hypotenuse is, so you just call it x. And then we just did one like this. X on the bottom, that kind of sucks. Get it out of there. Times by x times by x. So you got x times the sine of 34.4, and that's equal to 7.1. To get x by itself, undo the times. So divide this side by sine of 34.4. Divide this side by sine of 34.4. And then whatever this is on your calculator, that will be the value of x, which was the hypotenuse. And now that you got the hypotenuse, you can either do some trig, you can do opposite with adjacent, you can do tangent and find the adjacent, or you can do Pythagorean theorem and find it, whichever you're best at, whichever's fastest. You get the same answer. Okay, trig, you gotta draw your own picture again. Find the tangent of theta if the cosine of theta is 3 over 11. Okay, cosine, This is adjacent over hypotenuse. I'm going to skip this guy. You got to draw a triangle. Put 90 here and put theta. It doesn't matter where if you put theta here, this piece is the opposite, this piece is the hypotenuse, and this piece is the adjacent. So it doesn't matter where you put theta, just don't put it on the 90, put it on one of these acute angles. Okay, now if you put it here, that means 3 is the adjacent, so this piece is 3, and 11 is the hypotenuse, that's that guy. So we probably got to find this. Tangent is the TOA, so tangent is opposite on top and adjacent on bottom, so I do have to find the opposite. So I'm just going to do Pythagorean theorem. I'm going to do 3 squared plus x squared equals 11 squared. So 9 plus x squared is 121, minus the 9, x squared equals 112. Okay, 112. Now I gotta undo the square, so I square root, and it doesn't say. If it says leave it in a decimal, that's pretty slick, because you just do square root of 112. But if they don't, they want it left in a radical. This 112 is not a perfect square, so you gotta break it down. 112, just divide it by 2. Or 4, or let's go by 4. 112 divided by 4. Okay, that's 4 and 28. You can break down 4 to 2 and 2, and 28 to 4 and 7, and 4 is 2 and 2. So you got a 7, you got a 2, you got a 2, you got a 2, you got a 2. So here's a pair of 2's, they come out. Here's a pair of 2's, they come out. So on the outside I got a 2 and I got a 2. Times them, so you got 4, and on the inside you got 7. So this is going to be 4 square roots of 7. Okay, now tangent, put the opposite on top, so 4 square roots of 7 goes on top, and put the adjacent on bottom. 3 is going to go on bottom. Okay, so that is the tangent of theta, 4 square roots of 7 over 3. Okay, do this one on your own. Figure it out. Find the cosine of theta. Let's do the story problem. Razzy's going to make a skateboard ramp. He's got a board that's 4 feet long. He wants it to be 2 feet off the ground, so you got to draw a picture. And it's going to be a 90-degree triangle. So Razzy's, this is the ramp. His board, this is 4. He wants it 2 feet off the ground. That's the height right here, so that's 2. The question is, what angle is this right here? How wide does he have to open that ramp off the ground? So if you're going to go from here, this is the hypotenuse and this is the opposite, so you need to use O with H, and the trig fraction that uses O with H is sine. So you're going to do sine from theta, and the fraction is going to be O on top, 2 and 4 on bottom. So now let's find theta. Let's ditch the sine. So it's not divide, it's inverse. To undo trig, you gotta do the inverse. So it's sine inverse, sine, the inverse of sine, 2/4. Punch that in, and you should get 30 degrees. And that is it. Okay, just to keep you honest, quadratics. These came from quarter 2 final. So factoring, this is like the 1,000 club stuff we've done. This first one, if we factor it first, I can shrink it down. I can divide them all by 5. If I divide them all by 5, it's going to be 5 times n squared minus 1365 divided by 5. Okay, that is 13n plus, and 150 divided by 5 is 30. 50. Whoa. 150 divided by 5 is 30. Okay, now let's break this down. So 5, how they times to get n squared is n and n. And we're looking for something that timeses and gives you 30, but adds and gives you 13. So if you start going through the factors of 31 and 32 and 15, 3 and 10, 5 and 6, you're going to use 3 and 10. And it's going to be a negative 3 and a negative 10. Because they must times together to give a positive 30. And a negative times a negative is positive, but they've got to add together and give you a negative 13. So that is it. Okay, the next one, you can't factor anything out. You can't simplify it all. It's as simplified as it's going to get. So, when it starts with a 2, here's what we're going to do. We're going to go 2m squared, add blank, add 25. We're going to change it from a trinomial, 3 pieces, into a polynomial with 4 pieces. We're going to bust up this middle. We're going to bust up 15m. So you times the first and the last. 2 times 25, and that is 50. So now we are looking for something that timeses and gives you 50, but adds and gives you 15. And that's going to be 10m and 5m. Okay, they're going to times, give you 50. They add and give you 15. Now we're going to do grouping. So once you've got a polynomial with 4 terms, you just group them. So this first 2, I can take a 2m out of, so it's going to be 2m times m plus 5. And the second group, I can factor out a 5, so it's going to be 5 times m plus 5. And now group 1 and group 2, they both have an m plus 5. So I'm going to factor an m plus 5 out of both. So it's going to be m plus 5, and then what's left over is 2m plus 5. And that is the factored form of 2m squared add 15m add 25. The third one is a special case. They're perfect squares. And when you recognize they're perfect squares, how they times to get the 4x squared is 2x, 2x, you just take the square root. How they times to get a minus 25 is a positive and a negative 5. And these are conjugates. So if you got one that's plus and one that's minus, when you factor it, or when you distribute, your middle term will be 0. So that's why they don't have a middle term. Okay, solve for the variable. Okay, this equation is not linear. This equation is quadratic because the exponent is 2. So if it's quadratic, you should know the picture looks like some kind of a parabola. Solve for the variable. Let's get everything on the same side. Let's move this over. So let's minus 12r minus 12r. So you got 11r squared. These all zero out. Minus 12 equals 0. Okay, if you can factor it, it's pretty slick, but if you cannot factor it, if it is a quadratic equation, you can always use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and that's a slick way to solve any quadratic equation. So you need the value of a, which is 11. You need the value of b, which is not there, so it's a 0. And the value of c, which is a minus 12. Okay, now you've identified a, b, c, just plug them in. So x equals negative b plus or minus the square root of b squared. Always put b in parentheses and then put the square outside of it. Minus 4 times a times c all over 2a. Okay, now type this in on your calculator. And you should have this. Let me erase some stuff. Okay, you've got a plus or minus square root of 528 all divided by 22. Okay, now 528 is probably not going to be a perfect square. It's not. So 528, you got to bust up 528. 528, it's even. You can cut it in half. 528 divided by 2 is 2 and 2, 64. That's even again. So maybe I'm going to skip a bunch. 264 divided by 8. Because I don't want to sit and break in half, break in half, break in half. So if you skip, it'll go faster. Divided by 8 and 33. And 8 is 2 and 2 and 2. And 33 is just 3 and 11. So there's a pair of 2's that come out. There's a pair of 2's that come out. So 2 out, 2 out. 2 times 2 is on the outside you got 4. On the inside you got just a 3 and an 11. So you got 33. And then it's plus or minus. And on the bottom you've got 22. And the 4 and the 22 play together. So divide them both by 2. So your final answer is plus or minus 2 square roots of 33 divided by 11. Okay, I'll leave the last one for you to do on your own. Bring it back, check your answer. And that's it.